Question 8. G and H moving along straight roads which are at right angles to one another. Speeds are 6 meters and 8 meters per second respectively. G and H. H is at crossroads and G is 200 meters away. Okay, we can do it from either side coming towards the crossroads, but we'll do it this way. G and H. So H is at crossroads. Just move it off to the side. And we'll do our y-axis in this direction. So H is here. G is here. 200 meters. And we have G going in this direction. And we have H going up. We can say the velocity of G is equal to, what is it, 6 in the I direction, 6I plus 0J, and the velocity of H is going up, so it's going to be 0I plus 8J. So we get the velocity of G relative to H, and we'll be able to find the shortest distance. So it's the velocity of G minus the velocity of H. That's going to be equal to 6 minus 6I minus 8J. That's the velocity of G relative to H. The tan of the angle is going to be 8 over 6, which is 4 over 3. So the sine of theta O over A 5, so the sine of theta is 4 over 3, or you identify the O as 4 or 8. So it's O over 8, it's not 4 over 3, 3 over 4, 4 over 5 even, 4 over 5, getting tired, 4 over 5, okay. So we have 6I minus 8J, so we're coming down in this direction, positive, negative. Shortest distance is here, and theta is in here. So we can say that, I'll move up to the top here, we can say that the sine of theta is equal to x over 200. So 200 by the sine of theta, which is 4 over 5, is equal to x. 44s are 160 meters. So the second part, there are 160 time interval for 164 meters. So this is 164. This is 164, and we have this one here, which is 160. So let's have a look at what we call this y on the bottom this time. So we have 160, the hypotenuse is 164, and y, so y is the square root of 164 squared minus 160 squared. That works out to be 36. By 2 is equal to 72 meters. So the speed at which they're traveling, I don't think we got it, is a 5 again. No, it's the square root, the magnitude of V, the velocity of G relative to H, the square root of 6 squared plus 8 squared, which is going to be 10 meters per second. So you can see here that 72 divided by 10 is going to be 7.2 seconds. That they will be within 164 meters of each other. Question 9. A is traveling 45 degrees east of north. 45 degrees, and B south of east. So we have positive, positive, and we have positive, negative. So if we look at the velocity of A first before we look at these questions, we're going to be looking at the velocity of A relative to B, and then the shortest distance, and then the time interval, the same kind of questions we've been looking at already. So the velocity of A is going to be 16 cos 45 in the I direction plus 16 sine 45 in the J direction, which is 16 over root 2, which is going to be 8 root 2 in the I direction, plus 16 over root 2 in the J direction. So 1 over root 2 is root 2 over 2. So we're going to have 8 root 2 in the I direction plus 8 root 2 in the j direction. The velocity of B again is 45 degrees and it's 20, so we have positive negative, so we have 20 cos 45 in the I direction minus 20 sine 45 in the j direction. That's going to give me 20 by 1 over root 2, which is 20 over root 2, which is 10 root 2 in the I direction minus 10 root 2 in the j direction. The velocity of B. The velocity of A relative to B is equal to the velocity of A minus the velocity of B, which is equal to 8 root 2 minus 10 root 2. So I'll do it in one step. 8 root 2 minus 10 root 2, so minus 2 root 2 in the I direction, and 8 root 2 minus minus, so 8 root 2 plus 10 root 2, so that's plus 18 root 2 in the j direction. So we're asked for the shortest distance if B is 10 kilometers north of A. Okay, so we need the sine of the angle, so let's look at the tan of theta here. The tan of theta is 18 root 2 over 2 root 2. Let's actually do a graph here, because I think, let's look at why this might be incorrect. Just thinking here. So I've got my B, I should have done this first. B is 10 kilometers north of A, so let's say B is at the origin and A is here. And the velocity of A relative to B is minus plus, so it's going in a minus plus direction, so it's like that. I think this is the x-axis, and this is my angle. The tan of theta in this case is opposite, which is my x value, over the adjacent, which is my y value. So actually the tan of theta here is the x over the y, so it's 2 root 2 over 18 root 2, which is equal to 1 over 9. Just be careful, always draw the diagram, it will help. So we have theta, opposite over adjacent, square root of 81 plus 1, square root of 82, so the sine of theta is equal to O over H, 1 over the square root of 82. So the right angle was in here, that's why this diagonal is the hypotenuse, but now at the shortest distance we have A and B, velocity of A relative to B. And my shortest distance, my right angle, is here now, so 10 is the hypotenuse, theta is the same angle, so we can say that the sine of theta is equal to x over 10, so 10 sine theta is equal to the shortest distance, so 10 by 1 over the square root of 82 is equal to x, so x is equal to 1.104, so that's in kilometers, so in meters that will be 104 meters. The last part is the visibility, 2 kilometers, so they remain in contact for 2 kilometers. Just do a slightly bigger diagram this time. A and B. Velocity of A relative to B. The shortest distance was 1.104. And we're looking for when they're within 2 of each other. So down here and down here, 2. So we have this right angle triangle where the hypotenuse is 2 and this side is 1.104. So we're going to have the square root of 2 squared minus 1.104 to be squared, and we're going to have to multiply that by 2, so that's going to be 1.667 by 2, 3.335, and I think the speeds here were in meters per second, weren't they? So if we convert this back to meters, or do we have that we can use the relative speed? I don't think we got the magnitude of the velocity here. We didn't, so the magnitude of the velocity of A relative to B is the square root of 2 root 2 to be squared plus 18 root 2 to be squared, and this works out to be 4 root 41. So we bring this down. Relative distance over relative speed is going to be my 3.335 divided by 4 root 41, and that's going to give me 0.1302. And if I multiply that by 60, that's in hours. I think we're asking here. Let me go back and see what we're asked for. We'll do it in minutes. 7.812 minutes. So 7.812 minutes. And if I multiply the 0.812 by 60, I'm going to get 7 minutes. And 0.812 is going to be 48 and 18 over 25. So I'd round off to 7 minutes 49 seconds. So just be careful with where we can go wrong here with this tan of theta. Always draw the diagram for the velocity of one relative to the other. Something like this. Question 10a is 200 kilometers west of B. B is traveling due north at 10 kilometers an hour. So we can put it away. The velocity of B is 0I plus 10J. A is northeast at 20 kilometers an hour. The velocity of A is equal to 20. Northeast is 45 degrees, just in there. Positive, positive. So 20 cos 45 in the I direction plus 20 sine 45 in the J direction. We're asked for this correct at 2 decimal places, so let's put the velocity of A into decimals. So it's going to give me 14.14 in the I direction plus 14.14 in the J direction. So the velocity of A relative to B is equal to the velocity of A minus the velocity of B, which is going to give me, I can do this in one step because we have zeros in here, it's going to be 14.14 minus 0, so 14.14 in the I direction, and then we're going to have 14.14 minus 10, so plus 4.14 in the J direction. So we do a little sketch. A and B. A is west of B, so we have B, we have A. The velocity of A relative to B is positive, positive. So we're going in this direction. So I have my angle in here. I have 200 kilometers, 200 kilometers apart. So the shortest distance along here. So let's just check, we can see it, what it's going to be here, but my theta is going to be, the tan of it is the opposite, which is the Y, over the adjacent, which is the J, or the J and the I, just because we got it wrong the last question. So the tan of theta is equal to 4.14 over 14.14. So we need to get the sine of theta. The angle here might be easier. Theta is equal to the inverse tan of that. So what's theta going to be here? Theta is equal to 16.32 degrees. So looking for the shortest distance, then we can say that the hypotenuse is 200, so the sine of theta is this x, the shortest distance, over 200. So 200 by the sine of 16.32 degrees is going to be the shortest distance. That's going to give me 56.200, 56.2, and we're dealing in kilometers. So the distance between them 1 hour after they were nearest, so it's going along this direction. 1 hour after they were nearest each other, we need to get this bit here. So if we get the magnitude, in 1 hour it will travel, the magnitude is in kilometers an hour, so the velocity, the magnitude of the velocity of A relative to B, square root of 14.14 squared plus 4.14 squared is 14.7336, 14.734, and that will be in kilometers an hour. So that's, if I take this right angle triangle out, this is my 14.734. This is the 56.2, and they were nearest each other. So x in this case is the square root of 56.2 squared plus 14.734 to be squared. That is a 5. So x will be the distance between them after 1 hour, 58.099. Doesn't say round off, but we'll round this off to 58.1 kilometers. So in the next video we'll look at questions 11, 12 and 13.